Hello everyone, welcome to my channel Ghiloo once again. So in this video I'll be discussing from question number 12 onwards of miscellaneous exercise of determinants. In the previous videos I discussed up to question number 11. You can follow the playlist there on my channel. So without any further delay, let's get started. So we want to first represent the LHS in the form of delta. So let delta is equal to the given determinant. You can clearly note that there is a symmetry in row 1, row 2 and row 3 that we can make use of. If we subtract each other, you can see that there can be something in common that we can pull out of the determinant to make it simpler. That's what we will do. We are applying R2 to R2 minus R1 and R3 to R3 minus R1, keeping R1 as the pivoted row. Now this will take our calculations to a much simpler level. So now as you can clearly see here that we can bring out y plus x times y minus x from y square minus x square, and same with the third row. And in the third column itself you can see that p of y cube minus x cube are in the form of a cube minus b cube. So ultimately we can take y minus x and z minus x common from both row 2 and row 3 respectively, because one element common, that is y minus x, is present in both row 2 and row 3. So now as you can clearly see that we need to simplify it further. For that we will be taking the third row, will be transforming the third row to R3 minus R2, and as you can see I'll be getting 0 as the first element of third row. Now you can see why I did this very operation that brings z minus y out from row 3, as it is a common element throughout row 3. So finally we are left with this determinant. So there is no relevance to simplifying it once again, as it is the most simplified form. Now I will be expanding it along row 3, as expanding it along row 3 will be the easiest one. We change the signs of x minus 1 y minus z, as negative will get cancelled out, and after simplifying the determinant we are getting this. Alright, so if you solve it, you will be getting the required answer. If you just simplify it, you can do it, it's just algebra. So it will be 1 plus p x y z, and this is what we were required to prove. This is equal to RHS, hence it is proved. Coming to the next question, question number 13. So once again a similar problem here, but a much trickier and easy one. We are assuming delta to be the given determinant. Now to solve it, we'll be applying a very simple trick. If you observe carefully, if we add the elements of column 1 to column 2 and column 3, you can see that I'll be getting a plus b plus c in the entire first column. This is what we will be making use of here. So applying C1 to C1 plus C2 plus C3, it is the problem is designed this way. We are getting a plus b plus c. So now we can easily take a plus b plus c common out of column 1. Once you have all the 3 elements in column 1 to be 1, you can make any 2 of them 0 to simplify the determinant to the farthest possible extent, and that is what we'll be doing here. I'll be making the elements of row 2 and row 3 to be 0. So I'll be transforming row 2 to row 2 minus row 1 and row 3 to row 3 minus row 1. So we are left with now there is nothing more to be simplified. You can clearly expand it along column 1, and as that will be the easiest one. So we expand along column 1 we get delta is equal to times just solving the determinant, and we have this. Simplifying that, you will be getting 3ab plus 3bc plus 3ac. Now you can take 3 common, and hence you get a plus b plus c times ab plus bc plus ca, and that is what is required. This is equal to RHS, hence proved. I hope you have no doubt. Coming to the next question, question number 14. We need to prove that this determinant is equal to 1. Once again, this is a simple one. If the trick is caught out, we assume the determinant by delta. So we need to apply just 2 transformations, and that will do. This is as simple as that. So we'll be making the first 2 elements of column 1 to be 0. For that we apply row transformation like this, exactly like this, and the problem will be done in 2 steps. So after transformation we have the given determinant as. Alright, now we can simplify even more. For the sake of convenience, we'll be simplifying R3. So R3 goes to R3 minus 3R2 is the transformation we'll be applying on it, so that the row 3 comes as 0, 0, 1. It's the simplest form of expression. So after that we'll be left with the determinant as shown. So now we can expand it along C1, and inevitably we'll be getting 1 as the answer, as is very evidently visible. So that is 1. Hence delta is equal to 1, proved. Coming to the next question, that is question number 15. This is going to be the last question of this video. So here we are assuming delta to be the given determinant. Just by simple observation we can unfold the problem here. So what I will do here is just first expand the elements of column 3. Now there is a strategy that I will use. See, here in the first column we have sine alpha, sine beta, sine gamma, and in the third column as the expansion we have a part as minus sine alpha, sine delta. So see, in the entire column 3 we have sine terms as sine delta, sine delta, sine delta multiplied with sine alpha, sine beta and sine gamma. This is what we are trying to bring in column 1 too. In column 1 also we'll be bringing the same thing, and for that we'll be dividing and multiplying sine delta to column 3, and in the same way we'll be multiplying and dividing cos delta to column 2, and these will be simplifying the problem to such a great extent that the problem will be solved. Sine delta and cos delta, so we'll be having sine alpha, sine delta and so on. Now you can take it further in many ways, but what I will do is I'll be adding column 1, I'll be transforming column 1 to column 1 plus column 3, as sine alpha, sine delta term would be getting cancelled from this, and just see what I'm getting here. Having done this, you can clearly see that column 1 and column 2 are exactly identical to each other, and that makes the value of determinant 0, as we know that if any row or column all the elements are identical of it, the determinant value becomes 0. So this simply comes out to be 0 in 2 steps. We write it, since column 1 and column 2 are identical, the value of the determinant delta is equal to 0. Hence we proved it. So this was it for today. I hope you have no problem. If you have any kind of problem, please feel free to use the comment section. We'll be meeting in the next video where we'll be discussing the rest of the questions of the whole chapter. Thank you very much.